Hey everybody, this is John. I'm putting together a navigation module for SAO 162, and I have this one presentation that I wanted to record and share with everybody. I know it's come up throughout the course, some ideas about navigation, especially mapping compass skills, and this idea of declination, which is something we'll explore in this presentation. But for this one, this is a pretty quick presentation. I've got about 15 minutes or so and a few slides, and I kind of want to run through parts of the compass, define declination and its effects on map and compass use, and lastly, kind of discuss some ways that compasses can aid with simple navigation techniques. This was something that we were definitely going to do in the field during our session 3 on campus, but here we are online. So hopefully this can help. I know we've done some of the digital navigation with regards to Caltopo and Avenza. There's a whole host of resources out there, but I think it's good to know the analog techniques as well. So basic parts of a compass. I don't need to read this out loud, but maybe pause the video and then take a look at this compass. If you haven't already, go ahead and pull out your compass and just know the basic vocabulary of the compass. Here's another few different kinds of compasses. The compass down the bottom right, that's called a clamshell compass. That's the kind that I carry, and I recommend it. It gives you a little bit more precision with regards to sighting and applications. I think everyone is familiar with this from their 164 projects, but the compass points to magnetic north or true north, depending how the compass is set up, and you move around the different parts of the compass: north, east, south, west, and back to north. North is 0 degrees, east is 90 degrees, south is 180 degrees, and west is 270 degrees. And you can use either the numbers or the cardinal directions. They're both totally appropriate. And learning how to use a compass appropriately is going to have some kind of really helpful effects when you're trying to determine slope aspect or if you're making observations, because your compass may not be pointing to the exact direction that you think it is, and that's what we're going to kind of unpack in this lesson. And there's this idea called declination. Declination is the difference between true or geographic north and magnetic north on land maps. For those of you who sail or have a background on water, it's called variation, but on land maps, we call it declination. And this is important because our compasses, if left untouched, they point to magnetic north, which is different than true north, the direction that a map points. And so you might be recording your observations or recording your aspects, and you could be off by 10 degrees or so here in Colorado. So here's a picture of that. If you look over on the left side, geographic north, that is what maps point to. It's a geographic north pole. But there's also this idea of magnetic north. The Earth's, the next slide talks about some of the components of the Earth, the core, but the magnetic north is constantly changing, and declination is constantly changing, and maps are routinely getting updated. If you come over to the image on the right here, it shows you some of the differences between true north and magnetic north. The compass needles on these compasses are all pointing to magnetic north. And that's going to be different depending where you are in the U.S. If you're somewhere in the Midwest, magnetic north and geographic north or true north are the same. But as we move east or west, that number changes. A bit more on declination. So as I said before, it's the angle between magnetic north and true north. It's caused by the motion of magnetic material in the Earth's core. The Earth is made up of a bunch of heavy metals, and it rotates at a different rate than the outer mantle. The material is magnetic, and as it rotates, it changes declination over the years. So declination is considered positive if it's east of true north, and negative when west of true north. So here's back to the map of the U.S. Here's a line where 0 declination, so true north equals magnetic north as you move to the center of the country. But as you move west, I know this sounds a little bit counterintuitive, but as you move west, our declination increases to the east. And that's because true north is east of us. So here in Colorado, I'll put the mouse right here, there's a 10-degree east declination. So as magnetic declination does vary from place to place and with the passage of time. So how do you find declination? Here's a map from the Front Range of Colorado. If you've spent some time in the Jefferson County open space, you might recognize this. This is Green Mountain and Dinosaur Ridge. But on any kind of map that you build on CalTopo or map or USGS quad that you find, declination will be posted down at the bottom with all the map key components. So what we see here is an N that points to true north and an MN, which is 8 degrees. That means the declination in Lakewood as of this fall was 8 degrees east. And that's just a picture, a blown up picture of that. And so all the USGS quads that you probably own, as well as all the maps you make on CalTopo, they have this little symbol, and that gives you the idea of declination. And if we are pretty much west of the Mississippi, our declination is going to be east, and it's going to get larger the further east, the further west that you get. So declination, if you go back to this slide, where if you're out in California, your declination might be 12 degrees east. I know when I work out in the Pacific Northwest and Washington and Oregon, I always have to reset my compass. Otherwise, my magnetic north is going to be very different than my true north just coming from Colorado. And that can add up to errors over time. So how do we account for this declination? So you can add or subtract declination when you use a compass. Few things just to point out. Your compass will always point to, if you don't adjust your compass for any sort of declination, your compass will point to magnetic north. And your maps, most standard topographic maps, point to true north. And so if you need to account for declination, when you go from magnetic north to true north, you actually add the declination to your magnetic bearing to get your true north bearing. So if I take a measurement in the field with my compass, it's going to be a magnetic north measurement. If I want to make that a true north measurement, I add the declination to it, and that allows me to get the true bearing. If I'm in Vermont, I'll do the opposite. So for a true north bearing to magnetic north bearing, you do the opposite. So if I measure a bearing on a map and I want to get a magnetic bearing to use on my compass, I then subtract the declination from the true bearing to get the magnetic bearing. You might measure a bearing on a topographical map in the field, then you want to follow that bearing on your compass. So you're going to measure it on your map and then subtract it and follow it with your compass. And there are a bunch of videos on Canvas that go over taking bearings and that go over taking bearings in the field and taking bearings from maps. The easy solution is, if you never want to deal with declination, is you buy what's called a set and forget compass. And the nice fancy compasses like the Silver Rangers and the fancy Sunto clamshell compasses, they have a declination feature that you can set. You can set declination, and then your compass always points to true north, which means your compass will always be in sync with your map. Really handy feature. Then you can forget everything I just said about accounting for declination. So I personally own a set and forget compass, and I'm not adding and subtracting when I'm in the field. Imagine I'm in a whiteout with a bunch of clients on a glacier, and I'm trying to measure something from a map and then add and subtract. It gets kind of tricky. So I just use a set and forget compass. But if you don't have a set and forget compass, you'll need to know how to account for declination. Some of the whys behind it. So if in Arizona, which is west of the Mississippi, Arizona has a declination of 12 degrees east, you can see that the magnetic north arrow is 12 degrees off from true north. So in order to get to that true north, you have to add 12 degrees. I think take a second to look at that drawing. I think that really explains the why behind the addition and the subtraction. Similarly, if you're in Vermont and you have a declination of 15 degrees west, you can see magnetic north is 15 degrees west of true north in this image, you're going to need to do the opposite. So the way I remember it is I say truth is greater than magnetism in Colorado, knowing that my compass is my magnetic north and my map is my true north. So my true north is always greater than my magnetic north. So then that helps me figure out that when I need to subtract and when I need to add with regards to declination. So compass to map, I add because my magnetic north is less than my true north. Map to compass, I subtract because my true north is greater than my magnetic north. An example of that, shooting a bearing from Berthoud Pass up to some point on Vasquez Peak, you can see My true north is 286.2 degrees north, and my magnetic north is 277.9 degrees north. So my declination is around 8 degrees and change east in that part of the state. So just as a review, what is a bearing? We've talked about bearings a little bit in this class. I've mentioned them in this previous lecture so far, but it's a navigational tool. It's the horizontal angle between the direction of an object and another object, or between it and true north. So basically, you take a measurement, and it's a difference between that measurement and true north. Navigation is using maps and compasses. So as we use this term navigation, it's technically, we're using maps and compasses. We take bearings in the field with a compass. We can also take bearings from maps. As I said, there's a bunch of videos on D2L, but a bearing, it gives us basically a handrail or a trajectory to follow. And there's a variety of techniques to use it. You can shoot off in the distance. You can shoot intermediate landmarks. You can shoot back bearings to make sure you're on the same line. There's a bunch of great resources online. I'll continue to populate Canvas with that, but do make sure to watch the videos and start thinking about how you can apply bearings to your fieldwork. One nice thing is if I'm in the field and I'm shooting a bearing with my compass and I'm going from a field bearing to a field bearing, there's no need to account for declination because I'm just following the compass. We call these direct bearings. You can also take a back bearing in the field. That can be really helpful. Some of these applications, as I mentioned, there's this idea of intermediate landmarks, lateral drift, whiteout navigating. So these are some applications of shooting bearings. You might be on a above tree line and the sun comes out for a second in a whiteout, and you can shoot a bearing to a rock, and you know that rock's where you want to go, and you can follow your compass in that direction. But really, for the avalanche science program, I think this is a really important application, is accurately measuring slope aspect. If you are constantly shooting bearings with your compass, and your compass isn't accounted for declination, you're recording a magnetic north bearing, which is going to be anywhere between 8 and 10 degrees off of the actual slope aspect. So that's one thing to consider when you're recording observations or snow profile data. Record your true north. Record your true north bearings. Or you can always just kind of record northeast as opposed to deciding whether it's 80 degrees or 90 degrees. You could record east as opposed to saying whether it's 80 degrees or 90 degrees. But if you're going to give a number, make sure you give a number that's to true north. So as wrap up, hopefully that was helpful. You don't find yourself stuck in a whiteout without knowing how to use your compass and going back from be able to take bearings from map to compass and compass to map. I wish we could do this in the field, but no, there's tons of resources on Canvas. There's some videos. There's a handout that an American mountain guide living in Canada wrote, talks about navigation. So hopefully this is just a bunch of skills that can help build up your tool belt and allow you to stay safe, stay found, and record good data while you're out in the field. Thanks so much, and hope everyone's doing well. And as always, let me know if you have any questions. Thank you.